Hello students, welcome back to the next part of the lesson units and measurement. We have already finished up till the topic of dimensions and dimensional analysis, and in a previous class I had told you how we can employ this method, this understanding in solving several questions. Now today we will cover a very important topic, that is errors in measurement. Measurement is the foundation of all experimental science and technology. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. So, an error, from the Latin error meaning wandering, is an action which is inaccurate or incorrect. In some usages, an error is synonymous with a mistake. In statistics, error refers to the difference between the value which has been computed and the correct value. Every calculated quantity which is based on measured values also has an error. So, error is actually the difference between the actual value and calculated value of any physical quantity. We shall distinguish between two terms, accuracy and precision. Now, you can check this picture in order to have a better understanding of accuracy and precision. What can you understand by observing these three pictures? In the first picture, it is written accurate, not precise. In the second picture, it is written not accurate but precise. And in the third, it is written accurate and precise. Now, with the help of this picture, can you understand some basic knowledge regarding the meaning of these terms accuracy and precision? The accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. Experimental values that are close to the true value, those are referred to as the accurate values. You can see the picture. But what about precision? Precision tells us to what resolution or limit the quantity is measured. A measure of how close a series of measurements are to one another. A measurement of how exact it is. The accuracy in measurement may depend on several factors, including the limit or the resolution of the measuring instrument. For example, suppose the true value of a certain length is near 3.678 centimeter. In one experiment, using a measuring instrument of resolution 0.1 centimeter, the measured value is found to be 3.5 centimeter. While in another experiment, using a measuring device of greater resolution, say 0.01 centimeter, the length is determined to be 3.38 centimeter. The first measurement has more accuracy because it is closer to the true value, but less precision. Its resolution is only 0.1 centimeter, while the second measurement is less accurate but more precise. Thus, every measurement is approximate due to errors in measurement. So, all measurements of physical quantities are uncertain and imprecise to some limit. There are three sources of errors. Firstly, human error, that is due to negligence or inexperience of a person. We may not be following the exact procedure, We may not be able to note down the measurement properly, so due to sheer negligence or inexperience of a person, there may be some error in measurement. Secondly, faulty apparatus. The instruments that have been employed to carry out this process of measurement is faulty. It is having some defect. And third, inappropriate method or technique. If you are not following the exact procedure, there is always a procedure for carrying out the measurement. If you are not carrying out the exact procedure, there may be some error. So, in general, the errors in measurement can be broadly classified as systematic errors and random errors. Let us first of all study about random errors. The random errors are those errors which occur irregularly and hence are random with respect to sign and size. These can arise due to random and unpredictable fluctuations in experimental conditions. Example, unpredictable fluctuations in temperature, voltage supply, mechanical vibrations of experimental setups, etc. Personal errors by the observer taking readings, all these are included in random errors. For example, when the same person repeats the same observation, it is very likely that he may get different readings every time. Now, I would like to tell you one important error that often arises whenever we are making use of some faulty instruments, that is the least count error. The smallest value that can be measured by the measuring instrument is called its least count. All the readings or measured values are good only up to this value. The least count error is the error associated with the resolution of the instrument. Now I would like to go back a little because I would like to tell you how can we reduce these errors. Using instruments of higher precision, improving experimental techniques, we can reduce the least count error. Repeating the observation several times and taking the arithmetic mean of all the observations, the mean value would be very close. The mean value means the average value would be very close to the true value of the measured quantity. So, in order to reduce random error, it can be reduced by taking several readings of the same quantity and then taking their mean or average value. Now, coming to systematic error. The systematic errors are those errors that tend to be in one direction. They occur when all the measurements of physical quantities are affected equally. These give the consistent difference in the readings. Reasons of systematic errors. The systematic errors may occur due to zero error in measuring instrument, poor calibration of the instrument, incorrect calibration on the measuring instrument. Now let me tell you a little bit about the different types of systematic errors before we get into how can we reduce systematic errors. Now primarily there may be some instrumental errors. What are instrumental errors? Instrumental errors that arise from the errors due to imperfect design or calibration of the measuring instrument, zero error in the instrument, etc. For example, the temperature graduations of a thermometer may be inadequately calibrated. It may read 104 degrees Celsius at the boiling point of water, whereas it should read how much? 100 degrees Celsius. In a vernier calipers, the zero mark of vernier scale may not coincide with the zero mark of the main scale, or simply an ordinary meter scale may be worn off at one end. This might be one type of systematic error. Secondly, imperfection in experimental technique or procedure. To determine the temperature of human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature. Other external conditions such as changes in temperature, humidity or wind velocity during the experiment may also systematically affect the measurement. Lastly, personal errors that arise due to an individual's bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precautions. For example, if you by habit always hold your head a bit too far to the right while reading the position of a needle on the scale, you will introduce an error due to parallax. Systematic errors can be minimized by improving experimental techniques, selecting better instruments, and removing personal bias as far as possible. For a given setup, these errors may be estimated to a certain extent and the necessary corrections may be applied to the readings. Like for example, whenever we are using instruments like vernier calipers, slide calipers as you call it, or screw gauge, we always take into consideration the zero error, and if there is any zero error, we have to either add it or subtract it from the final measurement. We are having two types of zero errors, positive zero error and negative zero error. So we can remove the zero error and then only we will be getting the exact measured value. Now we will come to absolute error, relative error and percentage error. Suppose the values obtained in several measurements are E1, E2, E3 and so on up till AN. Suppose we make n measurements. Then we will obtain different values as A1, A2, A3, A4, A5 and so on up till AN. The arithmetic mean of these values is taken as the best possible value of the quantity under the given conditions of measurement. So you all know how to find out the arithmetic mean. You simply add up all the values and divide it with the number of observations as you can see in the picture. A1 plus A2 plus A3 plus and so on up till AN divided by N. That can be also written as summation of AI divided by N. So, absolute error is simply the amount of physical error in a measurement. The magnitude of the difference between the individual measurement and the true value of the quantity is called the absolute error of the measurement. Absolute error is positive, negative or 0. In plain English, the absolute error is the difference between the measured value and the actual value. Now here I would like to tell you one thing. As I was telling you that absolute error can be positive, negative or 0. Let us show you how. Suppose the absolute error is denoted by the symbol delta A. Then what should be delta A1? It should be equal to A1 minus A mean. Now here you should remember what is A mean. As I told you, A mean is equal to A1 plus A2 plus A3, and if suppose we have took n observations divided by n, and this can also be written as this is the summation sign. So this is the general way of writing down the expression for A mean. So if delta A1 is equal to A1 minus A mean, delta A2 is written as A2 minus A mean. So can anybody tell me how to write down delta AN? It should be equal to AN minus A min, isn't it? So the delta A calculated above may be positive in certain cases and negative in some other cases. But absolute error means when we put this sign, this will always be positive. This will always be positive. Now, let me tell you one more thing. The arithmetic mean of all the absolute errors is taken as the final or mean absolute error of the value of the physical quantity A. So we can write down delta A mean equal to mod of delta A1 plus mod of delta A2 plus so on mod of delta AN divided by n, and that may be written as summation I equal to one to n, because there are n terms, delta A I divided by n, isn't it? So if we do a single measurement, the value we get may be in the range A mean plus minus delta A mean. That is, A will be equal to A mean plus minus delta A mean. Or we may write down isn't it? This implies that any measurement of the physical quantity A is likely to lie between these two values. The value of A will be lying between these two values. Instead of the absolute error, we often use the relative error or the percentage error. The relative error is the ratio of the mean absolute error, that was delta A mean, to the mean value A mean of the quantity measured. So we may write down relative error as delta A mean divided by A mean. When the relative error is expressed in percent, it is called the percentage error. So we may write down delta A, that is the percentage error, as delta A mean divided by A mean into 100. Okay, so in this manner we can find out the absolute error, relative error and percentage error. So relative error is the ratio of the absolute error of the measurement to the accepted measurement. The relative error expresses the relative size of the error of the measurement in relation to the measurement itself. When the accepted or true measurement is known, the relative error is found by the formula, as I was telling you. Now, when the relative error is measured in percentage, then percentage error is mean absolute error divided by mean value, that is delta mean divided by A into 100. So, in this manner, we can do the percentage error. Now, we will be solving a couple of numerical questions based upon the concepts of absolute, relative and percentage error. Then these formula will become pretty much clear to you all. But I would like to tell you that you have to go through the text over and over again, because this is a new concept for you all, and I have seen that many students finds a little bit of confusion when it comes to solving numerical problems based upon this concept. So I would like to suggest that you follow some books, any reference book that you may like to be easy for you for understanding this concept in a much better way. Thank you.